Welcome to the 6th in the Naze32 series. In the previous videos we've done the basic configuration, then we did advanced configuration, doing things like calibrating the ESCs and setting the radio up perfectly. Then we spent some time setting up things like sonar, minim OSD and the VBAT and low voltage alarms. In this video what we're going to do is we're going to add a GPS to the Naze32. In this one, we'll just talk a little bit about the GPS. It's not straightforward, but if you follow this video, you should have it working pretty quickly. We'll go through how we're going to check the settings on the GPS that you've got. This is actually a NE-06, a Sirius, C-R-I-U-S, NE-06, or a CN-06 will work as well. These are boards that I use an awful lot on my models, particularly the multi-Wii series, and they work fantastically well, so this is one we'll use here. You can use other ones, but you just have to just keep that in mind when we get to a couple of the bits about setup. Once we have checked what this is running at, the baud rate and the data that's coming out of it, then we'll look at how we're going to connect it to the Naze32. Couple of options here depending on whether or not you're using PWM, which is where you have a separate cable for each of the channels on your receiver, or you're using PPM, which is where you have one cable that gives all of the channels through. So depending on which one you've got depends on where you plug this in. We'll plug it in, then we'll go into Cleanflight configurator, we'll turn it on, we'll check it, and we'll also talk about some of the other things that you need to have turned on with the new GPS modes that you'll have to make this work well, i.e. compass, barometer and angle. So let's get started. First thing to talk about is what GPS can and can't do. The GPS code in the Naze32 is coming on in leaps and bounds, and the system performance now will be completely different from the system performance in a couple of months. It's changing that quickly. Because of that, just be careful. Some people have struggled with this, and occasionally, sometimes the answer is wait a couple of weeks for a new version to come out and it'll be fixed. It gives you two more modes when you get the GPS installed and working: a GPS hold function, and GPS hold will try and maintain the craft's position in 3D space, and a GPS return to home or GPS home function. Now let's talk about these briefly. GPS hold, as I said, will kind of keep it in one position. I would always turn on the barometer as part of that, so not only will it maintain its position in the air, it will also try and maintain the height as well. It will not lock it down so it doesn't move in any way. It'll wander around the sky a little bit, so don't expect it to just hover like it's been drawn on the sky. It will move, and that's exactly the way it's going to. It'll just keep trying to correct to get back to the GPS coordinates it was at when you flicked the mode switch into GPS hold. GPS return to home, if you've watched any of my multi-Wii videos, you'll have seen this in action. Similar code for part of this here. When you flick the switch, the board will return back to where it was armed, and that's really important to note. So when you arm the board on the flight line before you take the craft off, that is where the craft will remember and try to fly back to. That's interesting to note because it means you need to make sure you have a GPS lock, a 3D solid lock on the flight line before you arm the board and take off. Otherwise that home position isn't stored and return to home won't work, and you'll get some very interesting results if you try and use return to home without the home GPS coordinates being set. You do need a compass for this to work. As I've already mentioned, you are going to need several other modes in conjunction with the GPS hold and GPS return to home. The compass is absolutely one of them. The way the GPS code works is it uses not only its position in the sky but also the direction it's pointing, so it knows what direction it needs to go in and also which motors it needs to use to go in that direction. If you don't have a compass on your board, GPS will not work. I think this is where some people are getting into a bit of a pickle. So make sure that you don't have the basic Funfly Acro one, or if you do, make sure that you have added an external magnetometer or compass to get this to work. as I said before, the model will not be rock solid. It will wander about in the sky. Accelerometers and everything, the craft uses a whole raft of sensors to try and maintain its position, but it will try and maintain it. So it's good if you get it in a particular location. You know, you can flick it into GPS hold and take your fingers off the sticks to show off to your friends, but I would suggest that GPS hold is less interesting unless you want to have FPV and be able to look around using head tracking and a camera. GPS return to home is the mode that I use the most on my transmitters, and it's also great knowing it's there if you get stuck. Last thing to mention, if you have problems with a GPS where when you are trying to use things like GPS hold, and what the craft is actually doing this kind of movement in bigger and bigger, faster circles, that is very indicative that the problem is actually that the compass is getting interference. So always make sure that when you mount your GPS receiver, mount it as far away from all the electronics as you can. That will make sure that there's little interference for the GPS reception as possible, so that it gets a nice clear signal. And secondly, make sure that you're keeping the Naze32 board nice and far away from the power lines in the model, so that the power isn't affecting the magnetometer on the Naze32. Right, first thing we need to do then is we need to unpack this guy, plug him into an FTDI adapter, and then plug him into the PC and seeing how he's set up so we know how to set the Naze32. So let's do that now. So to connect the GPS to a PC, we're going to use this thing, an FTDI adapter. You'll have seen this in loads of my other videos, and if you're watching this series in sequence, you'll have seen us use one of these to set up the Minim OSD on-screen display. This is one with a special cable on it. This is something that I do so often. I actually have one that's just left made up with a cable ready to go. And what it's going to do is plug into the port on the GPS. Now on the GPS itself, you'll actually see it very clearly labels +5 volts, transmit, receive and ground, which is great. So what we need to do is plug in the cables from the FTDI adapter into the GPS, so that we can plug a USB cable into here and use a special bit of software to have a look at how this GPS is performing and behaving. Now let me just put a little slide up here to explain how you're going to do it. So very simple and straightforward. We're going to plug in the ground pin from the FTDI adapter to the NE-06. We're going to have the +5 volts to +5 volts. That's pretty straightforward. We're going to have RXI or receive to transmit, and then TXO transmit to receive. So you're going to cross those two wires over. Pretty straightforward stuff. So here is the bottom of the GPS, and we're just going to plug the cable in. Just double check that the red wire is +5 volts, black wire is ground, and to transmit and receive is plugged in. Okay, now we have that all together, and just so you can see the way I did this, I just put little pins on the end of the cable so I could plug them into the FTDI outputs. It makes it very straightforward and easy. Now we're going to plug this into the PC, and we're going to get a little bit of software and set the board up. So we have the GPS connected to the computer over the FTDI connector. So I've actually plugged a USB cable into the computer and into the FTDI connector. We have a solid blue light on the bottom of the GPS board, and we also have a little flashing green light as well. I've popped it on the windowsill so it has a clearer view of the sky, and I've let it run for a minute or two because it's the first time it started up, just to get a lock. Now there are two bits of software that we need to look at. The first is this configuration file. I'm actually going to put a link to this configuration file in the description of the video so you can download it. This is all of the optimum settings for the Naze32, and we'll look at that in a sec. The other thing we need is a piece of software that you actually use to look at what the GPS is doing and configure it. If you search in Google for GNSS config, you will find it. It's the top one. It's the u-blox.com site. If I click on that, it'll take us to the application and give us a link to download it. Now the link at the moment is version 8.13, you need to click and save that to your desktop, and this is the software that we can use to connect and interrogate what's going on with the GPS. The reason we're doing this is because we don't know how the GPS has been shipped to us. Because there are so many different providers, different versions of the board, you never know what you're going to get. There are a couple of options for baud rate and a couple of options for what information is being sent. We want it to just be sending the coordinates. So I've already got this running on my PC. So let me start uCenter and we can actually connect to the GPS and see what we've got here. Fantastic. So that's worked really well. So what we've had to do, if this wasn't working, we're going to receiver, make sure we're on the right port, and we can see it's defaulted to 9600 baud. The little green light at the bottom is flashing, and actually we can see the GPS is working beautifully. We can see our location on the globe, and we know, of course, see we've got a 3D lock, our location, number of satellites, loads and loads actually. We're obviously underneath a lot of the constellation right now. That all looks good to me, apart from the fact that there's a couple of problems here. One, 9600 is not an optimal baud rate. You want 57600 or 115200. You want a lot faster baud rate because you want the signal from the GPS going to the Naze32 about once every 10 times a second. 9600 won't be great for that. So the next thing we'll do is we'll actually use that configuration file that we just looked at to change these settings. The GPS is capable of sending an awful lot of information. So if I just turn on some more of these windows. Oops. Let's get as many on as we can. Okay, there's lots of additional information that we can see coming down from the GPS. We don't actually want all of this because this is all stuff that we're not interested in actually seeing or being sent to the board. So we want just the GPS coordinates going to the board fast enough so that we get a good resolution. So what we're actually going to do is, let me just turn some of these back off. We want to get back to kind of where we were. So now we will flash the GPS receiver with the optimal settings. So we're going to use that file. We're going to go into Tools, GNSS Configuration. We're going to find that file on the desktop. We're going to go into Desktop. We're going to find Painless 360 u-blox. We're going to open that. And this time we're going to make sure that one, store configuration into non-volatile memory is clicked, and we're going to click on File into GNSS. This is going to save it all up. Now once we've done this, because the baud rate and the settings are going to be changed on the GPS, we're going to have to reconnect, but that's expected. So I'm going to click on File to GNSS, and now we can see that we're getting lots of errors, but that's because the baud rate has changed on the receiver, so that's fine. So at the moment at the bottom we can see that we're still on COM9, but now we can see something's happening because we can see information coming across, but we can't see anything populating the screen. That is absolutely fine. What we need to do, let's get the map back, I like the map, is go into receiver. We're going to change the baud rate to 115200. And then magically we are back in business. You'll also notice now that over here it says that we're running at 115200 and we're running UBX or u-blox protocol. Now all of the stuff that we don't want the GPS to be sending has been stripped out, and we know the two settings that we need for the Naze32 for this to work. Okay, we have now done one of the hardest parts. So we will just exit this. So now we have it configured, let's look at how we can connect it up to the Naze32 before we do the final step with Cleanflight. So now we have the GPS configured, we need to make the cable up in preparation for plugging it into the Naze32. The way I've found is the easiest is this cable that actually comes with it is pretty good. All you have to do is just use a small pin, lift each of these little teeth up in the connector, and the cables pull out. What we need to do is pull all four of these, put a bit of heat shrink or protection around all four of the pins, and then we're ready to plug this into the Naze32. There are actually a couple of options for how we're going to plug this in together, depending on whether or not you have the standard pulse width modulation, or the one single cable that has 10 individual cables coming out, and you plug one of them into throttle, one into elevator, one into aileron, or whether or not you have a single 3-pin cable like we have on my model, where you are running all of the signals over one simple connector. First of all, let's talk about the one where you're using PWM, where you have each of the signals coming in on its own individual line using the 10-pin adapter that comes with the Naze32. We actually looked at this in the very first video in the series, and back then I mentioned that depending on whether or not you had a GPS connected or not depended on what the pin configurations were. Now, back in that first video we didn't have a GPS connected, so it was ground plus 5 volts, aileron, elevator, throttle, rudder, and then auxiliaries 1 to 4. If we're going to plug the GPS in, we have to move a couple of these cables around. So you're going to have to unplug some of the cables and move them around, and then double check that all your auxiliary connections and mode selection switches on your radio are all still working fine, because we need to plug in the GPS transmit into pin 3 and the GPS receive into pin 4. If, however, you're doing it like I am, then the connections are a little bit easier because you don't have those pins already used. You can just pop the connection straight on. So here we have the Naze32 on the left hand side, we have the NE-06 or NEO-06 GPS module on the right. Pretty straightforward stuff. We connect the plus 5 volts and ground to some spare power outs, either on the power modules, power out, a part of the ESC rails at the top, or you can also connect them potentially to 2 of the channels on the receiver, because that also has plus 5 volts and ground available. Then we connect receive on the NE-06 all the way back to pin 3, which is transmit, and we connect transmit on the NE-06 all the way back to pin 4, which is receive. So if you trace this out, you can see that transmit is connected to receive and receive is connected to transmit, just like we did on the FTDI adapter and just like we've done on the Minim OSD. If we have the 4 cables separated and covered so that they can't short anything out, then it's a pretty straightforward thing for us to plug these cables into our Naze32 ready for the final configuration. So let's just go and have a look at what that looks like in real life on the bench. So here we have the NE-06 or NEO-06 all plugged in. The plus 5 volts and the ground wires are coming over here into 2 of the connectors. So the ground's at the bottom, the plus 5 volts at the top. That's providing the power. And then the other 2 cables here, which are the green and the yellow. The green, which goes from receive on the GPS to transmit, which is pin 3, and pin 4, which is just here underneath the connector for the receiver. That is receive, and that goes all the way to transmit on the other end. Those have to be crossed over. That's one of the first things I would always check if this doesn't work when you've connected it to the model. So now we have it set. The other trick now is to find where you want to mount this on the craft. You want it as far away from all the other electronics as you can get it. You want minimum interference. So some people put it on top of a stalk, some people put it out the arm. You might have to try different things to see which works best for you. But before I actually stick it on the model somewhere, I'm going to plug this back into Cleanflight. We're going to enable the GPS configuration, and then we'll double check we can see everything working. And then we're done. Right, back to the netbook. So here we are back in Cleanflight, and as you can see in the right hand side, the GPS is all working. So let me go through the 3 or 4 steps that you need to do in Cleanflight to get everything working in the configuration that we've got. Remember, here we are using the PPM or single 3-wire servo cable to get all of our signals through. So there was 2 things I had to do. First of all, go into ports, and I had to select UART2 as GPS and then save and reboot. And the next thing I had to do was then go into configuration, go all the way down to the bottom, Make sure that I had u-blox and 115200 selected as the protocol and baud rate, because that's what we just set up using the GNSS configuration software. And then also put in your magnetic declination. You can look this up on the internet. If you give it your address, it'll give you an idea what your declination is off true north. This changes over time, so you probably want every 2 or 3 months to go in here and update this number. It just stops things wandering out too much. Then you click save and reboot again, and then when it comes back, your GPS light will be lit. Fantastic. 2 ways you can make sure it's working. One, obviously go into setup. You can see it's true, it gives my latitude and longitude. The other way to do it is pop into the GPS tab, and you can see all of the information about what's going on. So reasonable signal strength. Again, we've got it near the windowsill this time because it's actually connected to the craft, but we're looking in good shape. So that's how you configure GPS on a Naze32. Last thing we'll do is just have a quick talk about modes. We talked about this briefly on the way in. So now we have 2 additional modes, one for GPS hold and GPS home. I've got my GPS home set, so in the high position for the settings, it enables GPS home, but also at the same time I have my magnetometer and my barometer set. So when I flick my oh dear switch, so it flies back to me, not only will it fly home safe, it'll also maintain its altitude and make sure it's using the magnetometer, which I think, to be honest, I don't need that strictly speaking, but personally I like to see all 3 turned on at once. So thank you for watching. That concludes the main part. We'll have another couple of videos about auto-tune and 1 or 2 other pieces in the series, but hopefully now, for those of you that were looking at GPS, you now know what you need to do. Thanks for watching. Please like, subscribe, and happy flying.